Welcome to stage 07, where your Linux finally starts talking to other machines, and we're kicking it off with just 4 letters, ping. Picture Tom. His customer says the website's down, his own browser confirms it, and now he needs to know, is it his internet, the server, or something in between? Ping is the answer, a tiny sonar pulse that asks one simple question, is anyone out there? So here's what ping actually does. It sends tiny ICMP echo request packets to your target, thinks sonar pulses heading out into the dark, and listens for the replies coming back. From that, you learn 3 vital signs all at once. Is the target reachable? How fast is the round trip in milliseconds? And how reliable is the connection? Meaning, are any packets getting lost along the way? And by default, ping just keeps going 1 pulse per second until you stop it with Ctrl+C, at which point it hands you a neat summary of the whole conversation. Let's actually try it. The syntax couldn't be simpler. Just type ping followed by an address like pinggoogle.com and hit enter. You'll see replies streaming in line by line, each one showing the sequence number and the round-trip time in milliseconds. And here's the critical bit on Linux. It won't stop on its own. You have to press Ctrl+C yourself. That's when ping closes the session and prints that lovely summary at the bottom. Packets sent, packets received, packet loss, and your mine, average, and max latency. Now let's decode what you're actually seeing. A typical reply line breaks into 4 parts. 64 bytes is the size of the echo packet. The host name tells you who answered. ICMP, ESIC is the packet's number in the sequence, handy for spotting which ones went missing, and time is the round trip in milliseconds. Then at the bottom, the summary tells the real story. 0% loss means a healthy heartbeat, 5 to 10% and your video calls will stutter, and 100% loss means the target is either down, blocked, or unreachable. The min average and max values show stability. The tighter that spread, the steadier your connection. Now, by default, ping runs forever until you hit Ctrl+C. Fine when you're watching, useless in a script. So let's meet the 3 flags that put you in control. -cc sets a count, ping-c5, google.com sends exactly 5 packets and stops. -i changes the interval, drop it to half a second for rapid-fire testing, and -w sets how long to wait for each reply so a dead host fails fast instead of hanging. Combine them, ping-c1-w2 host, and you've got Tom's perfect "is it alive?" check in a single line. And here's that perfect check in action. A customer pings Tom, "Your site is broken," and instead of panicking, Tom runs 3 quick pings. First, 8.8.8.8, his internet's fine. Then google.com, DNS works, the wider web is healthy. Finally, the customer's actual server, destination. Host unreachable, 100% packet loss. Aha, in under 30 seconds, Tom's narrowed it from "something's broken somewhere" to "the server itself is down." That's the power of a layered ping triage. But here's the catch. Tom learned the hard way. Silence from ping doesn't always mean death. Try pinging Microsoft.com and you'll get 100% loss, yet the site loads perfectly in your browser. Why? Many big companies deliberately block ICMP at the firewall because attackers once used ping to scan networks. So remember the rule: ping success means alive for sure, but ping failure means maybe dead, or maybe just blocked. Always confirm with another tool, like curl, which is exactly where we're headed next. And that's why ping has a family. Think of it as the first responder. It shows up, checks for a pulse, but when it can't get an answer, 3 partners step in. Curl tests the actual web service, so when ICMP is blocked, you still know if the site is alive. Traceroute maps the path your packet takes, showing exactly which router dropped the ball. And dig handles DNS, because sometimes the server is fine, but the name just won't resolve. Together, these 4 cover almost every connectivity question you'll ever face. Now it's your turn, and don't worry, ping is completely safe to experiment with. Start with Google's DNS at 8.8.8.8. The C4 flag just caps it at 4 packets so it doesn't run forever, and you'll see your latency in milliseconds. Then try wikipedia.org. Same idea, but notice DNS has to resolve the name first. And finally, ping Microsoft.com, where you'll likely see 100% packet loss, proving exactly what we just learned. The site works fine in your browser, but ICMP is blocked at the door. And just like that, Lesson 31 is complete. You've got a working network heartbeat detector in your toolkit. But ping only answers one question: is the host alive? Next up, curl takes you further, actually pulling data back from those machines. API responses, JSON payloads, config files. Stage 07 is just getting started. See you in Lesson 32.